Hello and Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 from ED 2492A. We will discuss about sampling distribution of sample variance. So these are our group members: Najah binti Ismail, Norida Rashidah binti Ramli, Nur Salsabila binti Norizan and Nona Suha binti Muhammad Nasir. Our learning objective from this topic can be summed up as 3 learning outcomes. Firstly, finding out whether the variance obtained from the sample match the population variance. Secondly, a representative sample of the population will be used in order to obtain the population variance. And lastly, able to apply the concept of population variance to real-life scenarios.
So what is sampling distribution for the sample variance? Sampling distribution of the sample variance refers to the distribution of the sample variance that you will obtain from multiple random samples taken from the same population. It is a theoretical distribution that describes how the sample variance statistic varies across different samples of the same size. Then, use this formula to calculate the sample of variance for each of these random samples. The sample variance is a measure of how much the values in a sample vary from the sample mean. The sampling distribution of the sample variance is the distribution of this sample variance obtained from all possible random samples of the same size. It describes how the sample variance statistic varies from sample to sample.
So now we move to the theory of this topic. First, the distribution of sample variance tend to be skewed to the right in the distribution of sample variance, and the variance of the sample represent the variance of the population, making the variance of the sample a valid and biased estimator of the variance of the population. As a result, the expected variance of a sample is the same as the variance of the population. Not to forget, the chi-square distribution with degrees of freedom V has a few properties. Firstly, the mean of the distribution is equal to the number of degrees of freedom, which represent by mu equals to V. And secondly, the variance is equal to 2 times the number of degree of freedom, which represent by sigma square equals to 2V. So now, let us focus on the small red box here. For a small n distribution is heavily skewed to the right. As the value of n increases, the distribution becomes more symmetrical as it becomes larger. The symmetrical distribution is called as the bell curve. As n increases, the bell curve becomes more pronounced and also the shape of the distribution becomes more predictable.
For the theorem, this is formula that we use, which is n minus 1 times s squared over variance squared. For our information, chi-square test just only used for sampling distribution of the variance.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Najah binti Ismail with matrix number 2023305281, and I will show you our first question. So the question asks to assume that a random sample of 30 employees has been selected from all employees in company A, which is known to have a standard deviation of 15. What is the probability that the sample variance will fall between 185 and 400? So, the very first step is to determine the information given by the question. The question given that a random sample of 30 employees has been selected and the standard deviation is 15. So, we know that our n is equal to 30 and our standard deviation, which is denoted as a sigma, is equal to 15. Also, as the question given, the probability of the sample variance will fall between 185 and 400. So, we can write as P as square more than 185 and less than 400. Next, we proceed to the calculation part. The formula is chi-square n minus 1 more than and less than n minus 1 times with s square divided by population variance, which is denoted as a sigma square. So we will get a chi-square with a degree of freedom 29 more than 23.84 and less than 51.56. The next step is to find 23.84 and 51.56 in the table of chi-square using a degree of freedom V equal to 29. let's focus on this chi-square table. We can see that 23.84 lies on 0.70 while 51.56 lies on 0.005. And lastly, we can say that the probability of the sample variance falling between 185 and 400 is 0.705 as the total of 0.70 and 0.005. That's all from me. We will proceed to the next question.
Now let's proceed with another question. Suppose an English subject teacher wants to calculate the variance of test score for a population of 5th grade students. A sample of 25 students randomly selected and the sample variance is determined to be 230. The teacher wants to determine the probability that the true population variance exceeds 400. On the question given, just like the previous question, the first step is to identify the crucial information or data, which is the sample of 25 students we denoted as n, and also the sample variance S square, which is given the value 230. The next step is to figure out what the question wants, which is to find the probability that the true population variance exceeds 400. So to avoid making a mistake, let's highlight the question first. Then we can write probability population variance, which is denoted as sigma square greater than 400. Now, recalling the formula for calculating a chi-square statistic, which is chi-square equal to n minus 1 times sample variance divided by population variance. The third step is we substitute all the values given in the formula and calculate them. Then we get the probability of chi-square greater than 13.8. The last step is to determine this probability. Consult a chi-square distribution table with degrees of freedom equal to n minus 1, which here is 24. Locate the value 13.8 in the table chi-square distribution with 24 as degree of freedom, resulting in probability of 0.95. As this question mentions exceeds 400, we don't have to minus the result with 1. Therefore, the probability that the true population variance exceeds 400 is 0.95.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sasabila binti Nurizan. My student ID is 2023J89825. So today I will solve the question 3, which is the IQs of individual at school were randomly selected. A sample of 30 students' IQ is randomly selected. Then the IQ are normally distributed with a standard deviation is equal to 20. Find the probability that the sample variance are less than 300. So let's solve together. Okay, the solution for this question is, based on the question given, the first step you need to do is you need to identify the important information in the question, which is given sample of students selected is equal to 30. The standard deviation here is equal to 20. Okay, as we know, the standard deviation is a square root of variance. So the variance here is 20 squared. Okay, then the sample variance given is less than 300. Okay, here we have a formula to find the probability of sample variance. So the formula is degree freedom multiplied by sample variance and divide it with variance. This is approximate to chi squared with n minus 1, or we call as degree of freedom. Okay, then we write P, which is probability, and then we put the bracket beside the probability. Okay, in the bracket we write chi squared is less than the formula that was given before. Okay, enter the all value given in formula and we start to calculating. Okay, then you will get probability of chi squared is less than 21.75. Okay, as this question asks you to find the probability is less than the sample of variance, so we need to put negative in front of 21.75. Okay, and then it will become chi square less than negative 21.75. Then you need to find that the 21.75 value in the table of chi-square distribution. Okay, for this, we get 21.75 in the chi-square table is equal to 0.8. After we get the value in the table, you need to calculate the exact value, which is 1 minus 0.8 to get the probability of the sample variance is less than 300. We need to do 1 minus value of chi-square table because it is less than symbol. And then the final answer we will get, the probability is equal to 0.2. I think that's all for this. We proceed to the question 4, which is the question 4 is about a random sample of 14 people has been selected from the supermarket to complete a research about the percentage of people buying kitchen item monthly. Given the variance is equal to 676, so the question asks, what is the probability that the sample variance is more than 500? So let's resolve it. The solution for the question 4 is, step 1, we need to identify what is the most important information given in the question. So here, given that the sample of people selected is equal to 14, variance is equal to 676, and the sample variance here is more than 500. Next, we go for the step 2. We have a formula to find the probability of sample variance. So the formula is degree of freedom, which is n minus 1 multiplied by sample variance and divide it with variance. This is approximate to chi-square and degree of freedom, which is n minus 1. Okay, we go to the step 3. Write P, which is probability, and then put the bracket. In the bracket, write chi-square is more than the formula that was given before. Enter all the value given in formula and start to calculate the all equation. Then you will get the probability of chi-square is more than 9.62. Okay, next we go for the last step, which is step 4. In this step, you need to find the 9.62 value in the table of chi-square distribution. When you find in the table, you will get the 9.62 value is equal to 0.7. So the final answer here is probability of sample variance is equal to 0.7. I think that's all for this question.
Now let's proceed with another question. A company randomly selects a sample of 25 employees to assess their project completion times. The project completion times are normally distributed with a standard deviation of 15 days. Find the probability that the sample variance of project completion times is less than 186. So the first step is we acknowledge the information given from this question. Here we get n equal to 25, population standard deviation equal to 15, and sample variance equal to 186. As we all know, the standard deviation is the square root of variance, so the population variance denoted as sigma square is 15 squared. Next, we need to figure out what the aim of this question, which is to find the probability that the sample variance of this project compilation times is less than 186. So to avoid making a mistake, we highlight the keyword of the question first. Then we can write probability as square less than 186. Now using the same formula, the chi-square equals to n minus 1 times sample variance divided by population variance. Calculate this probability. Here we substitute all the value given, which is n equal to 25, s square equal to 186, and sigma square equal to 15. Then we find the probability of chi-square to be less than 19.84. Next, to determine this probability, consult a chi-square distribution table with degrees of freedom equal to n minus 1, which here is
24. Locate the value 19.4 in the table chi-square distribution with 24 as degree of freedom. Here I will show you how to get the answer. So we get the result equal to 0.7. As this question mentioned less than 186, we have to minus the result with 1. So 1 minus 0.7 equal to 0.3. Therefore, the probability that the sample variance of project completion times is less than 186 equal to 0.3.
Do you know that this topic can be applied in our life? Let's get to know the real-life application that is related to this topic. First and foremost, this topic can be used in environmental studies to analyze the data that is related to environmental factors such as atmospheric science, ecology, social science, and many more. To be clear, it is a study about human interaction with the environment for solving complex problems. Next, it can be used to analyze survey data and make inference about the preferences and behaviors of a target population. It is a process of determining the viability of a new service or product through the research conducted directly with the people. And lastly, this topic can be used to assess and manage risks associated, such as in finance and insurance. For example, anything that is related with investment, insurance policies, and other financial products.
Next, the application that related with our life is, as example, factory produce a certain product and the quality control team takes sample from each production batch to assess the product's quality. The variance in the sampling distribution helps determine the consistency of the product quality. A smaller sampling distribution variance indicates the production process is more stable and reliable. Next, in medical, in a clinical trial, researchers often take random samples of patients from a larger population to study the effects of a new drug. Understanding the sampling distribution variance is essential to assess the reliability of the results. A higher variance may indicate the observed effect could be due to random chance rather than the effectiveness of the drug. So, as conclusion, we can conclude that the sampling distribution variance measures how much the average value of different samples can vary. As sample size increase, the variance tends to decrease, making estimates more reliable. Smaller variance means more precise result. It is crucial for constructing confidence intervals and conducting hypotheses in statistics.
That's all from us. Thank you for listening.